Have you ever really looked at, say, your water bottle or maybe the casing on your phone, even arts inside your car? They seem simple, right? But there's this hidden world of really precise engineering behind how they're made. And that's what we're diving into today, our mission, to unpack the fascinating differences between two key ways plastics are made, blow molding and injection molding. We're using the sources you sent us to get right to the heart of it. So the big question is, how do manufacturers actually choose one versus the other? And what does that choice mean for the plastic things you use every day? Stick around, because we're going to uncover some surprising stuff and give you a shortcut to understanding the why behind all that plastic.
Absolutely. And it's important to remember, while both processes end up making plastic products, the way they do it, their core differences are just fundamental. It dictates everything. Choosing the right one is crucial for manufacturers. Think of it like, are we building a solid brick house, or are we inflating a bouncy castle? Both structures, but totally different methods for totally different results.
Okay, yeah, that bouncy castle analogy clicks immediately. Let's start there then. Let's unpack the most obvious difference, what the final product actually is. With injection molding, you mentioned solid parts, things like intricate bits for electronics or bigger things like car dashboards, right? Solid stuff.
Exactly. Injection molding is the champion for solid parts, especially when you need, like, really fine details of structural strength. Think about your phone casing again.
Yeah.
And has to be solid, protective, right? It needs precise openings for buttons, ports. That's injection molding territory. But then contrast that completely with blow molding. That's specifically for hollow parts.
Oh.
Your water bottle, shampoo containers, milk jugs, basically anything designed to hold something, usually liquid or air. You can almost always tell just by looking, can you fill it up? Probably blow molded. Is it a solid, complex shape? Likely injection molded. It's a pretty clear visual clue once you know what to look for.
That makes perfect sense. A really clear distinction. Okay, so we know what they make, solid versus hollow. The next big question is how. Let's peel back the layers a bit on the actual mechanics. How do you get from melted plastic pellets to, say, a detailed phone case versus a simple water bottle? The processes must be pretty different.
Oh, completely different, yeah. With injection molding, you start with these small plastic pellets. They get melted down and then fed into the machine, usually by something called a reciprocating screw. But here's the really crucial part, that melted plastic is then injected, into a precisely machined metal mold under incredibly high pressure.
High pressure, okay.
Yeah, massive pressure. Think about forcing something thick, like hot glue, into every single tiny nook and cranny of a complex shape. That pressure is what ensures the plastic fills the entire mold cavity perfectly, capturing all those fine details and allowing for very tight tolerances, which is why it's great for those precise, solid parts.
Wow, okay, so the pressure is doing a lot of the work for getting that detail. I get that. But then, for blow molding, how do you end up with something hollow? If you start with melted plastic, you can't just inject air into a solid mold, can you? That wouldn't work.
No, exactly. That's where it fundamentally diverges. For blow molding, you still start by melting the plastic, but instead of forcing it into a final shape right away, you first create either a hollow tube of plastic called a parison, or sometimes a small solid preform. Then you place that soft, warm plastic shape inside a different mold cavity, and then you use air pressure compressed air to inflate it.
Ah,
It
yeah.
expands outwards, pushing the soft plastic against the cool walls of the mold. Kind of
Yeah.
like blowing up a balloon inside a bottle-shaped box.
Right, the balloon analogy really works there. Makes it easy to picture.
Yeah, that inflation action is what creates the final hollow shape. It's a simpler concept in some ways, but really effective for containers.
You mentioned versatility earlier, though. Is it just one type of injection molding and one type of blow molding, or are there variations, different flavors of these processes?
Good question. For injection molding, the basic principle is pretty consistent. Engineers mostly tweak things like the mold design, the type of plastic, the injection speed, and that pressure we talked about, to control wall thickness, surface finish, things like that. It's more about optimizing the parameters for a specific solid part. Blow molding, though, definitely has more distinct techniques you'll see.
Okay.
So there's extrusion blow molding. That's probably the most common for simple containers. You extrude a continuous tube of melted plastic downwards, a mold closes around it, pinches off the bottom, and then air is blown in through the top. Think milk jugs, detergent bottles.
Gotcha. Simple container.
Then you've got injection blow molding. This is a bit more precise. First, you injection mold a small, solid preform. It often looks like a thick test tube with the final neck threads already formed. That preform is then moved to a second, cooler mold, the blow mold, where it's heated slightly if needed, and then inflated. This gives you better control over the neck finish and wall thickness distribution. Think maybe cosmetic jars or some pharmaceutical bottles.
More precision there.
Exactly. And then there's the really advanced one, injection stretch blow molding. This is key for things like PT beverage bottles, soda bottles, water bottles. It starts like injection blow molding with the preform. But then before blowing, the preform is carefully reheated and mechanically stretched both lengthwise and radially while it's being blown.
Stretched. Why stretch it?
That stretching action does something really important. It aligns the polymer molecules in the plastic, making it significantly stronger and clearer. It also allows for much thinner, more uniform walls. That's how you get those incredibly lightweight but super strong and clear plastic bottles that can hold carbonated drinks under pressure. It's quite clever engineering.
Wow, stretching it makes it stronger and clearer. That's not intuitive, but it makes sense when you explain the molecules aligning.
Okay, so these different mechanics, different techniques, what does it all mean for the range of stuff they can make? Beyond just solid or hollow, how complex can each process get? Well, injection molding, because of that high pressure and the precision of the molds, it just has a much broader range of applications when it comes to complexity. It really excels at producing parts with super intricate details, complex internal or external geometries, very fine textures, and those really tight tolerances we mentioned. If you need gears, clips, housings where parts have to fit together perfectly, maybe with internal ribs or bosses, injection molding is almost always the way to go. That precision is often critical for function.
Okay, the go-to for complex, precise, solid parts.
Definitely. Now, blow molding is generally better suited for simpler, hollow designs. It's fantastic and really cost-effective for making billions of bottles and containers. But you wouldn't typically use it if you needed, say, a hollow part with really complex internal features or extremely precise, sharp details on the outside. It's just not designed for that level of intricacy. You trade some complexity for the efficiency of creating that hollow shape.
Right, simpler shapes, but great for containing things efficiently. This whole conversation has really illuminated the why behind these objects we just, use and toss without a second thought. So, pulling it all together, what's the main takeaway for our listener, whether they're thinking about making something or just looking at the plastic in their recycling bin?
I think the biggest takeaway is that every single plastic item you pick up is a result of a very deliberate engineering and manufacturing choice. It wasn't arbitrary. Understanding these core differences, solid versus hollow, high pressure versus air pressure, the different techniques, it's not just for engineers choosing a process for a project, though it's vital for that, considering cost, speed, material performance, but it also lets you, the user, appreciate the sheer amount of technical thought and expertise that goes into even the simplest looking plastic piece. It's about designing for purpose, optimizing for strength or weight or clarity or maybe complex function.
Absolutely. So the next time you're holding a piece of plastic, you have a much better sense of its story. Why some things are solid and detailed, others are simple and hollow. It's not random, it's not magic, it's just smart, precise engineering choices happening constantly, shaping the world around us, from, yeah, your phone case to your orange juice bottle.
Exactly. So here's a little challenge for you. Next time you grab a plastic bottle or look closely at an electronic gadget's casing, take a second. Feel it.
Mm.
Does it feel solid? Can you see intricate shapes or fine lines? Or is it clearly hollow, maybe with that telltale seam line running down the side from where the blow mold closed?
Okay.
You now have the basic tools to make a pretty good guess about how it was made, connecting that thing in your hand back to these really sophisticated industrial processes.
Right.
And maybe think about this. What would happen if you tried to make a soda bottle using injection molding? Or tried to make a complex gear using blow molding? The function would totally fail, right? It shows how critical that initial process choice is.
That's a great way to put it. Go out there, observe your world with this new perspective. You'll start seeing the hidden engineering everywhere, the intentional design behind everyday objects. It's actually pretty fascinating.